Question number 3 is also a word problem. Let's go through this together. The centers of two diagonal holes. Okay, so the holes are diagonal to each other. It's going to be like an angled line between these two holes. The centers of two, and we're talking about the centers here. That's another important thing to note. The centers of the holes is what we care about. In a locating plate are 22 centimeters apart. So if I was to just straight up measure with a steel rule or calipers or whatever, from center to center, it'd be 22. The angles between the center line of the two holes, so this is that line that's connecting the two holes, and a vertical line. Now in our past problems it was a horizontal line. It was an angle from the horizontal, but here it's from a vertical line. It's 50 degrees. And notice I have 3 significant digits here because of the trailing 0 with the decimal number. 1, 2, 3. What is the horizontal distance between the centers of the two holes? So we're looking for a horizontal distance. Let's draw this thing out so that we can conceptualize it. And again, I'm going to use AutoCAD. So I think how I'll do this is I'll go to Grid Snap, I'll go to Polyline, and I'm going to draw the angled line first. I'm going to draw the angled line first, and I'm going to use a center line because I know that this is going to be the distance between the two centers. Now the problem said it's 50 degrees from a vertical line. It's 50 degrees from a vertical line. So I'll draw a vertical line first, just so that I can see it. And I drew it at a random length. I'll also draw a horizontal line, and this is at a random length. Okay. I'll turn the grid off so that you can see it. And now I want a line that is 50 degrees from a vertical line. So here you can see that AutoCAD automatically measures it automatically measures angles from the horizontal. So to get it from a vertical line, I would need to subtract 50 from 90 degrees. You can see that if I have 50 from the vertical, I'm going to have 90 minus 50 from the horizontal, which is going to be 40. So 90 minus 50 is 40. I'll type in the length of the line at a random, or I'll type in the length of the line not at a random length at 22, because we're given the diagonal distance as 22 centimeters. So I'll type at 22, alligator symbol, 40. This is 40. Ooh, that's a long distance. This is because the 50 degrees, it's from a vertical line, and I can confirm this with a dimension in AutoCAD. I'm going to draw these circles just for fun, even though I don't really need to. How about a radius of 0.75, huh? So I'm conceptualizing. I have my problem here. I'll bring this size of the dimension up so that you can see it better. That's a little too big. There we go. All right. Next, what I'll do is I will draw this horizontal line a little longer, and then I'll do a vertical line here, and let me make that into a center line, just because. I can trim away the edges. And then let me also put in my dimension for this angled line. And I'll again bring up the scale. There we go. Let me change this to 4 too. Let me make sure they have the same scale. You know, just as a thing. It's not really necessary, but just to be to the book. Okay. So here I needed the 50 degrees to draw my problem. But if I was to use this triangle as the example, I would really want to use this angle right here, which is 40 degrees. Now, if you decided to go ahead and do this, do your triangle up here, that works too. It's not a big deal. Like if you decide to go and do this, it's not a big deal. That will work too. I'm just showing you here that depending on how you conceptualize your problem is going to change the angle that you use. So let's make a decision on what to use right now. I'm going to change line weights here. Change the line weight up on you. And I think I'm going to use the conceptualization that includes the actual angle that was given, just to be to the book. So now I'm going to take this, I'm going to snip a picture of it and start solving it. It took me a while, sorry. Whoa, where'd my part go? Didn't quite make it. There we go. Alright, let's start solving this thing. Or let's label it first and then start solving it. So we want to know the horizontal distance here. Let's call that A. Let's call this B just for fun. Let's call this H just for fun. And call this big angle B. And then here's our right angle. So to solve this, for A, I need to find a trig function that includes A and that includes the information that I know, which I know this angle and I know this length here. So let's see what we got. Let's try sine first. Let's do sine of 50 equals the opposite. That's this angle is opening up to angle A, so the opposite is angle A over the hypotenuse, which is 22. Well, would you look at that? We got our answer on the first go. Sine of 50 degrees equals A over 22 centimeters. I'm including my given information, and A, the unknown, is a part of the equation. So now I can solve this for A. To solve it for A, all I have to do is multiply both sides by 22 centimeters. The 22 centimeters cancel out here, and I'm left with 22 centimeters times sine of 50 equals A. I can go to my calculator. I can do sine of 50 times, what was that? 22 centimeters equals 16.852977746. I need to remember to round to the to the least accurate number that was given to me. So in the 22, I have 1, 2, 3 significant digits. In the 50, I have 1, 2, 3 significant digits. 3 significant digits is the lowest amount of sig figs that I have. So 3 significant digits it is. So my final answer, side A, which is a horizontal side, let me bring my calculator back up, is going to be 16.9. 16.9. And I can double check my answer in AutoCAD. I can put a dimension on this one. 16.85. Let's change the precision to, or sorry, let's change the accuracy to 3 sig figs, which would be a precision of 1 decimal place for this particular number. It's not true for all numbers. It depends on the size of the number. So 16.9, that's the answer I was looking for.